When an electrical conductor is larger than 40, a rubber gasket is required in the gutter opening. This requirement is based on electrical codes and standards designed to ensure safe and reliable electrical installations. A gutter, in this context, typically refers to a metallic enclosure, such as a wireway or auxiliary gutter, used to house and protect electrical conductors. These gutters provide a contained space for conductors, protecting them from physical damage and environmental factors. The opening in the gutter, where conductors enter or exit, needs to be properly sealed to prevent the ingress of moisture, dust, and other contaminants. These contaminants can degrade the insulation of the conductors over time, leading to electrical faults, short circuits, and potential safety hazards. A rubber gasket serves as a sealing element, creating a barrier between the conductor and the edge of the gutter opening. It is crucial when dealing with large conductors, such as those exceeding 40, due to the increased surface area and potential for greater exposure to environmental elements. The use of a rubber gasket ensures a tight seal, which is essential for maintaining the integrity of the electrical system. Firstly, the primary purpose of a rubber gasket is to prevent moisture from entering the gutter. Moisture can lead to corrosion of the conductors and metallic components within the gutter, increasing the risk of electrical failures. Secondly, the gasket helps to prevent the entry of dust and other contaminants, which can accumulate over time and affect the performance of the electrical system. Thirdly, the rubber gasket provides a degree of mechanical protection, cushioning the conductor against vibration and movement, which can cause wear and tear on the insulation. Fourthly, the presence of a gasket helps to maintain the overall environmental rating of the enclosure, ensuring that it meets the required standards for protection against specific conditions such as water ingress or dust accumulation. The size of the conductor is a critical factor in determining the need for a rubber gasket. Conductors larger than 40 have a greater surface area exposed to the environment, increasing the potential for moisture and contaminants to penetrate the enclosure. Additionally, larger conductors tend to generate more heat, which can exacerbate the effects of moisture and corrosion. The National Electrical Code, or NEC, provides specific guidelines for electrical installations, including requirements for sealing conductor entry points in gutters and other enclosures. These guidelines are designed to ensure the safety and reliability of electrical systems. The NEC typically references standards from organizations such as Underwriters Laboratories, or ALL, and the National Electrical Manufacturers Association, or NEMA, which provide detailed specifications for the design and construction of electrical equipment. When selecting a rubber gasket for use with large conductors, it is important to consider several factors. 1. The gasket must be compatible with the conductor insulation material to prevent any adverse chemical reactions or degradation. 2. The gasket must be sized appropriately to ensure a tight seal around the conductor. 3. The gasket must be made of a material that is resistant to environmental factors such as ultraviolet radiation, temperature extremes, and chemical exposure. 4. The gasket should meet the relevant industry standards and certifications to ensure its quality and performance. In addition to the rubber gasket, other sealing methods may be used to protect conductor entry points in gutters. These methods include the use of sealing compounds, such as silicone or epoxy, and the installation of conduit hubs or fittings that provide a watertight seal. However, a rubber gasket is often preferred for large conductors due to its ease of installation and its ability to accommodate slight variations in conductor size and shape. When installing a rubber gasket, it is important to follow the manufacturer's instructions carefully. The gasket should be properly seated in the gutter opening and securely tightened to ensure a tight seal. Over-tightening the gasket can damage it, while under-tightening can result in a leak. The use of a torque wrench may be necessary to achieve the correct level of tightness. Regular inspection and maintenance of rubber gaskets are essential to ensure their continued effectiveness. Gaskets should be inspected for signs of wear, cracking, or deterioration and replaced as needed. The frequency of inspection will depend on the environmental conditions and the type of gasket used. In summary, the requirement for a rubber gasket in a gutter opening when the conductor size exceeds 40 is a critical safety measure. It is essential to ensure a tight seal, preventing the ingress of moisture and contaminants that can compromise the integrity of the electrical system. By following the guidelines and standards outlined in the National Electrical Code and other relevant publications, electrical professionals can ensure that electrical installations are safe, reliable, and compliant with applicable regulations. Remember to always consult the latest edition of the NEC and other relevant standards for the most up-to-date information and requirements. This will help to ensure that electrical installations are performed safely and in compliance with applicable codes. Always adhere to safety protocols and use appropriate personal protective equipment when working with electrical systems. Incorrect installation or maintenance can lead to electrical hazards, including shock, electrocution, and fire. Consider that electrical work should only be performed by qualified and licensed professionals who have the necessary training and experience to perform the work safely and correctly. The selection of appropriate materials, including rubber gaskets and sealing compounds, is crucial for ensuring the long-term reliability of electrical installations. Choose materials that are compatible with the conductors and the environment in which they will be used. Pay attention to the environmental conditions in which the electrical system will be operating. Factors such as temperature, humidity, and exposure to chemicals can affect the performance and lifespan of electrical components. Choose materials and installation methods that are appropriate for the specific environmental conditions. Proper grounding and bonding are essential for ensuring the safety of electrical systems. Grounding provides a path for fault current to flow back to the source, tripping the circuit breaker and preventing electrical shock. Bonding ensures that all metallic components of the electrical system are at the same electrical potential, reducing the risk of shock. When working with electrical systems, always energize the circuit before performing any work. Use a voltage tester to verify that the circuit is de-energized before touching any wires or component. Follow lockout/tagout procedures to prevent the circuit from being accidentally re-energized while you are working on it. If you are unsure about any aspect of electrical work, consult with a qualified and licensed electrician. It is always better to be safe than sorry when dealing with electricity. Consider the importance of documentation in electrical work. Keep accurate records of all electrical installations, including the location of circuits, the size of conductors, and the type of materials used. This documentation can be invaluable for future maintenance and troubleshooting. Regularly inspect electrical systems for signs of wear, damage, or corrosion. Address any problems promptly to prevent them from escalating into more serious issues. Consider that preventive maintenance can help to extend the lifespan of electrical systems and reduce the risk of unexpected failures. Also consider the importance of energy efficiency in electrical systems. Use energy-efficient lighting, appliances, and equipment to reduce energy consumption and lower utility bills. Energy-efficient electrical systems can also help to reduce greenhouse gas emissions. Be aware of the potential hazards associated with working near energized electrical equipment. Maintain a safe distance from overhead power lines and other energized equipment. Use insulated tools and equipment to protect yourself from electrical shock. When working with electrical systems in hazardous locations, such as areas with flammable gases or vapors, use equipment that is specifically designed for those environments. Hazardous location equipment is designed to prevent explosions and fires. Consider the importance of electrical safety training for all employees who work with or around electrical equipment. Electrical safety training can help to prevent accidents and injuries. Stay up to date on the latest electrical codes and standards. Electrical codes and standards are constantly evolving to reflect new technologies and best practices. Be aware of the potential for electrical fires. Electrical fires can be caused by overloaded circuits, faulty wiring, and damaged equipment. Install smoke detectors in your home and workplace to provide early warning of a fire. Have a fire extinguisher readily available in case of an electrical fire. Know how to use a fire extinguisher properly. Regularly inspect electrical cords and plugs for signs of damage. Replace damaged cords and plugs immediately. Do not overload electrical outlets. Overloading outlets can cause them to overheat and start a fire. Use surge protectors to protect electronic equipment from power surges. Power surges can damage electronic equipment and cause data loss. Be aware of the potential for electrical shock when working with wet or damp conditions. Water is a good conductor of electricity, so working with wet or damp conditions can increase the risk of electrical shock. Use ground fault circuit interrupters, or GFCIs, in areas where water is present, such as bathrooms, kitchens, and outdoor locations. GFCIs can detect ground faults and quickly shut off the power, preventing electrical shock. Consider the importance of electrical safety for children. Teach children about the dangers of electricity and keep electrical outlets and cords out of their reach. Use outlet covers to prevent children from inserting objects into electrical outlets. By following these safety precautions, you can help to prevent electrical accidents and injuries. Remember that electrical safety is everyone's responsibility. This includes electrical safety for not only yourself, but for those around you as well. Electrical accidents do happen, and the electrical accident could potentially lead to a serious injury or even death.